Hello. That's an AI assistant created by Fabrizio. It's not real Fabri. Fabrizio is currently preparing the live streaming. Please, wait until he's back. He streams live programming content. He's pretty decent at programming and sometimes he's kinda fun. For now, enjoy this little funny story. Once upon a time in the mystical land of Blockchainia, there was a clever developer named Alice who decided to embark on a quest to build her very own decentralized application, dApp, using Solidity. With stars in her eyes and determination in her heart, she set out on her coding adventure. Alice started by sketching out her dApp's architecture, envisioning a revolutionary platform where users could trade virtual kittens. Yes, you heard that right, virtual kittens. She called her project CryptoKitties 2.0, the feline frenzy. Little did she know, she was about to embark on a journey filled with more twists and turns than a cat chasing a laser pointer. Our fearless developer began coding furiously, weaving together smart contracts with Solidity, the language of the blockchain. She created a contract to define the properties of each virtual kitty, including traits like fur color, eye shape, and purring intensity. But as she delved deeper into the code, she encountered her first hiccup. You see, Alice had underestimated the complexity of breeding virtual kittens on the blockchain. She forgot to account for one tiny detail: cats are notorious for their, shall we say, unpredictable behavior. Her smart contract was supposed to ensure that each breeding transaction produced a new, unique kitten. However, due to a bug in her code, users ended up with virtual kittens that were, let's just say, less than perfect. Instead of adorable furballs with fluffy tails, users were greeted with bizarre creations like kitty with elephant ears and octocat with tentacles. The CryptoKitties community erupted in laughter and confusion as these mutant creatures flooded the marketplace. Despite the chaos, Alice refused to throw in the towel. She rolled up her sleeves and dove back into her code.
Hello. Welcome back to this day 17 of building a cross-chain liquid staking bridge from scratch in live streaming. Welcome back. I'm glad to be streaming again. The last couple of days I've been very busy. I'm here in Lisbon right now visiting a dear friend. He had a crazy party. He is the CEO of Muro, which I talked about during the previous streaming. Right now I'm here with another friend of mine who is laughing at me because I'm doing this. But I'm enjoying it so much that even in Lisbon I'm not stopping streaming. Although now I think that I'm not gonna actually write code because I will be too loud, and here I'm like sharing the room with someone else. But this live streaming will be shorter, will be maybe I think it will last about half an hour, and yeah, it will last about half an hour, and I will go through the things that I did today and yesterday, and what I'm gonna do for the rest of the day, and what I'm gonna do before the end of the hackathon. So the hackathon ends on June the 2nd, but I plan to ship everything basically tomorrow. I'm gonna ship everything. I'm gonna create the live demo, so probably for that I won't stream it. So probably this will be the last episode of streaming of live building this buckle up. I got my smart contract hat. I got my smart contract water. Don't drink alcohol. Don't drink beer. Yeah, don't drink energy drinks because those are crap. It's bullshit, right? So just drink water is what is all that you need, right? Cool. I see that already 5 minutes passed by, so let's start and see what did I do during these 2 days. Let me share the screen. Okay, let me see the code. Yep. Okay, so all right. So let's try to make it bigger. I don't know, smaller, bigger. Yeah, like that. So I did some public relations. So this is the most important thing, maybe. I'm letting people know about this application that I'm gonna ship, and collecting feedbacks, and letting people try the application like privately, and I'm gonna also publicly post the website, the app. I'm gonna post the addresses of the contracts that I will deploy, and I'm gonna let me show you. Yeah, and I'm gonna verify the contracts on chain. So I'm gonna deploy on Amoy, on Fuji, and Sepolia, and Arbitrum Sepolia. Yep. So I'm gonna deploy here, and I'm gonna deploy front end with, well, one is Spheron or Vercel. Guys, I don't know. I probably will opt for the fastest thing. Spheron is quite okay, but maybe Vercel is even better. For sure. I don't know. But anyway, I'm gonna share the public link. Then I was able to collect 5K of link for each of these networks: Amoy, Fuji, Sepolia, and Arbitrum Sepolia. So I got a bunch of links token. Of course, this is not real money; it's test, okay, and I'm not rich yet. Maybe I will never be rich. So I got a bunch of test links, and I will allow people to actually bridge those links through test nets. Yep, that's what I'm gonna do. Well, not bridge, but teleport, right? So it's a test environment, but it's a real use case, because also in test, maybe you have some link in, let's say, Amoy, but you need to test your application in Fuji. So you just transfer this in Fuji using Buckle, right? So it's a test environment, but I will provide a real use case to test for users. And then I need to also improve the front end, like do some little fix on the interface, and I will also add some dashboard to see like to see how the application is behaving, and I will consider using some dgraph, some indexer. Okay. Yeah, even though it's a lot of work, I don't have this much time, but for me the priority now is to ship the contracts, and yeah, and this is the priority. And then the front end, I can I can improve it in these last few days in a chilled way, right? Okay, so this is what I did. This is like public relations, and this is what I'm gonna do actually in these next couple of hours. Then this is what the second important thing that I did is using create2 to create the pools cross-chain. What does it mean? That before I had a system where a ping pong system where when the user will give the command to deploy a pool in the current chain and in the destination chain, he will send a message cross-chain using CCIP, and on the destination chain a mechanism was triggered, and basically another message was sent back to the source chain, right, to add the deployed pool in the list of pools in the source chain. Okay, it's a bit confusing here. So I had this ping pong mechanism. So destination chain, I will call deploy CC cross-chain pools, like that, and then basically this is on source chain, I call this dest chain, basically CCIP receive deploy pool and send back a message to source chain. Okay, so chain where, so the source chain is the chain where deploy CC pool was called, right? Okay, so now I did something much more cool. So on the source chain, let's copy that for now. On the source chain, I have deploy CCIP CC pools create 2, and basically this thing, what happened here is deploy pool, and then compute the address of the pool cross chain and add it to the current chain deployed pool. Okay, so first I deploy the pool in this chain, in the source chain, right? Then I will compute the address of the pool that I'm going to deploy in the destination chain, and I'm going to add it to the to the mappings in the factory and in the cross-chain pool of the current chain. Okay, then a message is sent, and then basically on destination chain, CCIP receive, deploy pool. And that's all basically. And this is much more better for gas. It's better for gas because on the destination chain you basically run less code, right? So I'm gonna quickly go through it. So this is my pool factory, and I have this deploy cc pools create 2. I'm gonna show you how I'm doing that. So I think this kind of format can be better instead of like coding. Yeah, I should have shared the link of the streaming also in the Chainlink chat. Okay, who cares? I'm gonna just go through the code. Let me see if you can see the code. Yes, you can see the code. Okay, so I'm gonna go through the code and explain what I did instead of doing it live. It's quicker, easy to follow. So deploy cc pools create 2 is the, let's call it the entry point, and so let me quickly share this. I don't know, because the last time I shared this in the Discord, I basically was banned. So should I do that? Okay, just share it on Discord, who cares? Okay, so going through the create 2 usage in my application in the pool factory. So again, the pool factory is the contract that deploys pools cross-chain, right? And then it holds the addresses of all the pool deployed on the current chain, and also has a mapping of chain selector, CCIP chain selector, and pool address. So this one is the deployed pools, maps chain selector to pool array. Maybe I should give it a better name, like maybe like deployed pools on other chains, like that. Yeah, and this is the list of all the pools that I deployed in this current network. Okay, so this deploy cc pools create 2. So this one gets called, is the endpoint that gets called by whoever want to deploy a pool. So this is totally permissionless. I don't have any owner here. Anyone can go here and create a pool. Ideally, I should do other checks, but for the hackathon, I'm not doing that. So I have this one that I'm going to explain later on. So basically, first I deploy a pool here. So I have this function, deploy pool create 2, and this one actually deploy the contract using this thing that I actually looked into internet to do that. I'm not 100% sure of what's happening here because I'm not very good at assembly here. Okay, so this thing basically create use create 2 opcode to deploy a contract, and basically I have to deploy a contract. I need some bytecode, and this bytecode is the creation code of the contract. So like imagine like a bare skeleton of the contract, and then I'm adding to this bytecode all the parameters that I need to deploy the contract. So I'm adding the underlying token, the name, the cross-chain selector, router, blah blah blah. So the router in this case is is the router of the current chain, right? Because I'm calling deploy pool create 2 here from deploy cc pool create 2. So first step, create a pool in this network. Then I'm gonna compute the address of the pool in the destination chain, okay, and set it here as a sender, okay. Ignore set it here as a sender, but this is the important part. So I'm basically computing the address that will be deployed on the destination network. So this is the salt, which I just hard-coded to one. Can be done in other ways, but this is the fastest, and I'm short on time. And then basically this function is a private function. I'm gonna show you how I tested it. So compute address basically does the same thing of encoding all the parameters, and then I have an hash of these, and then I'm doing all this weird stuff to get the address. Okay, so I'm basically casting the result of the hash, yeah, with all these things. Okay, so I'm computing the address here, and then I'm gonna call the deployed pool, and I will add the cross-chain sender. So here, basically, I'm telling the deployed pool to accept messages from this computed address, which is not yet deployed, okay, but I know that it will be deployed, so it's very interesting. And then adding this in the list of yeah, the computer address in the list of the pool on the other chain, and then I will send the CCIP message deploy. Now, destination config is basically I need to know the router address of the and the chain selector of the destination chain. So here in this function, you now pass the destination chain ID, and you pass to this basically to this thing, the destination chain ID, and you will get basically all the destination chain configuration. So you have the chain selector, the router, and other things. And basically now this contract is also inheriting for this from this register. And so register is a contract which holds all these mappings, right? So network details, this is Sepolia, this is Optimus Sepolia, and so on and so forth. So every mapping has chain selector, router address, link address, and blah, 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 blah. So this is so interesting. And I managed like that to yeah, compute the address and avoid doing two transactions with CCIP. So I'm basically doing one CCIP transaction to deploy two pools. So this is so cool, actually. Okay, so I went through this. This is sending the message to the cross-chain, and then I modified this CCIP receive. So CCIP receive is receiving right now this data. It just now has just deploy pool function ID. Actually, I have something that I don't need it anymore. Yeah, I can just get rid of it. Yep, cool. Okay, so this is the CCIP receive. And function ID, deploy pool function ID, basically, if the function ID is this one, I can also actually avoid doing that. Maybe I'm gonna just remove that, or maybe not. Maybe I will leave like this. Yeah, we'll leave it like this, maybe. So deployed pool, deploy create pool. So right in this moment, I'm using deploy pool create 2 to deploy the contract, and the contract will be deployed at the exact address that I computed in the other chain, in the source chain before. Okay. So I'm passing all these parameters and then adding the cross-chain sender in the deployed pool in the destination chain of the deployed pool on the other chain, which is the source chain, right? And that's all, and that's all. And let me show you how I test this, because this is also interesting. So I have test here, and then unit, and then I have pull factory test. Yep. Okay, so test, deploy, pull, create two. So those functions, deploy, pull, create two, and compute address are private, well, internal functions, right? So I cannot call it directly. So what I did is I created a test contract for the create two functions, or internal functions in general, and I'm basically creating this test contract. Is a dummy contract which exposes publicly the functions that I need to test, right? And so I have this, and then compute address, and here I basically test, deploy, pull, create two. I will just instantiate a new contract, and yeah, and I will call deploy, pull, create two, compute address, and then assert that those are equal. Let's see. So last time I ran the test, they were working. Let's see if this forge test empty deploy pull create two. Okay. Okay, so it's working, yes. Confirmed. Okay, so yeah, this is using create two, and then I refactored the test. So this is the last thing I did actually yesterday. So I have protocol test. Right now I have a much better file for testing, because I have some cooldown and redeem function. Like I did these helpers functions to save time, okay, and to, you know, to avoid repeating all the time the code. And then I created this modifier, so the teleporter from Sepolia to Sepolia, deposited in Sepolia, these two modifier that I'm using sometimes, right? So now tests are shorter and much easier to read. So this is actually working. So this is crazy. This is very good. This is very good. What I'm gonna do now, I'm gonna close the streaming. So this was very quick. This was very quick. I think it's better. It's much easier. I should have started like this. Maybe, I don't know, because I think shorter is better. It's easier to follow, and it's like you just have some minutes to watch. You can come, let's say, yeah, live and ask questions. Otherwise you can, you know, have a recap of what I did. But anyway, this is too late, because probably this will be the last one or the second last one streaming, and then I for sure will do another live for the, yeah, a live reaction for on the 28th of June to yeah, to react to the final ceremony. Let's see if I get to win something or not. I hopefully I will get some money, guys, because I don't have a job, so I need to live somehow. So nice. So guys, as I told you, it's 28 minutes I'm streaming right now. So that's all. I'm gonna participate to the office hours, and then the rest of the afternoon I'm gonna just deploy the contracts. Okay, guys, thank you very much. Thank you very much, and yeah, reach out to me whenever you want. Yeah, and have a